Hello everyone. I believe you have always been wondering why 0 factorial is equal to 1 factorial. So in this video I'm going to show you guys why that is true using two different methods. The first method, we are going to use the factorial function, its expansion in the set of natural numbers, and the second method we are going to use the extended factorial function, otherwise called the gamma function. So let's get started. Now in the set of natural numbers, how can we write the factorial function? N factorial is simply the product from 1 to n of k. Expanding this, you are going to get 1 times 2 times 3 right up to n minus 1 times n. Now what about n minus 1 factorial? N minus 1 factorial is the product from 1 to n minus 1 of k. And expanding, we have n minus 1 factorial to be 1 times 2 times 3 right up to n minus 1. Now which relationship can we deduce that exists between n factorial and n minus 1 factorial? It is clear. Expanding n factorial, we expand to n minus 1, which is n minus 1 factorial, and we multiply with the last term n. So simply we can deduce that n factorial is equal to n minus 1 factorial times n. Now how am I going to relate 0 factorial and 1 factorial? Let's see what we are going to do. If I set n equal to 1, on the left hand side I'll be left with 1 factorial. On the right hand side I will be left with 1 minus 1 factorial times 1. Simplifying, I have on the left hand side 1 factorial, on the right hand side 0 factorial times 1, meaning that 1 factorial is equal to 0 factorial, and by conclusion we are saying that 0 factorial and 1 factorial are the same. So that is in the set of natural numbers, meaning we just play around by expanding the factorial function and substituting some value of n, which is n equal to 1, to suit our result. Now what about the gamma function, which is the extended factorial function? How can we... Okay, so let's look at how we can use the second method, that is by the use of the gamma function. Now the gamma function is simply the extension of the factorial function. The factorial function is based that its domain of definition is the set of natural numbers, but the gamma function extends that to the set of real numbers, meaning that we are going to be able to compute the factorials of negative numbers, fractions, integers as well by the use of the gamma function. Now I will start by relating the gamma function and the factorial function, the relationship that exists between the two. So simply, the gamma function, gamma of n, is equal to n minus 1 factorial, meaning if n is equal to 1, we have gamma of 1 is equal to 1 minus 1 factorial. So we can conclude that gamma of 1 is equal to 0 factorial. But what is actually gamma of 1? If we are able to show that gamma of 1 is equal to 0 factorial, or let's say if we are able to show that gamma of 1 is equal to 1 factorial, therefore we can conclude that 1 factorial and 0 factorial have the same value. Okay, now what is gamma of x? Is the integral from 0 to infinity of t to the x minus 1 e to the negative t dt. Here we are integrating in the t world, therefore x is a constant. So if I want to find gamma of 1, I will simply let x equal to 1, and I will obtain gamma of 1 to be equal to the integral from 0 to infinity of t to the 1 minus 1 e to the negative t dt. But we can simplify something here. T to the 1 minus 1 is simply t to the power of 0, and t to the power of 0 is 1. So our gamma of 1 can be written as the integral from 0 to infinity of e to the negative t dt. Now it is an improper integral, meaning that it contains a limit of integration or a bound which is not in the domain of definition of the integrand. Here our integrand is e to the negative t, and it is defined for all values of t in the set of real numbers. But our integral, we have as bounds 0 and infinity. 0 is a real number, therefore it is found in the domain of definition of e to the negative t. But positive infinity is not a real number, it is excluded from the set of real numbers, which is not in the domain of definition of e to the negative t. So by so doing, we are going to write this integral as a limit, because we cannot plug in infinity as a bound. So I consider any arbitrary constant a. It means gamma of 1 will simply give me the integral, the limit as a tends to infinity of the integral from 0 to a of e to the negative t dt. So gamma of 1 will simply give me the limit as a tends to infinity. Now integrating e to the negative t, we simply have negative e to the negative t. But remember, we have bounds as 0 and a. By so doing, imputing your bounds, we have gamma of 1 to be the limit as a tends to infinity of negative e to the negative a minus negative e to the power of 0. But we know the value of negative e to the power of 0 is simply negative 1, but the minus sign in red multiplies with the minus sign in black and gives us the positive sign. Now e to the negative t can be written as 1 over e to the negative a can be written as 1 over e to the power a, meaning that our gamma of 1 will give us negative the limit as a tends to infinity of 1 over e to the a plus 1. Now what does the limit gives us? Automatically it gives us 0, because e to the a tends to infinity as a tends to infinity. So 1 over e to the a will be tending to 0. So we can conclude that gamma of 1 is equal to 1, and we know 1 factorial is 1, so gamma of 1 is actually 1 factorial. Comparing the two equations, equation star and equation star star, gamma of 1 in equation star is 0 factorial, gamma of 1 in equation star star is 1 or 1 factorial. Therefore, we can conclude that 0 factorial is equal to 1 factorial, since gamma of 1 has a unique value. So I don't know if you loved this video. If you found the video interesting, I would like you to like the video and also subscribe to my YouTube channel. As well, you can share the video to your friends, your classmates, so they can see the beauty of mathematics with us together. Thank you.